How's it going, everybody? In this video, we're going to go ahead and take a look at our next topic, which is going to be Inter VNI routing. Now, it's going to take us a few minutes to unpack exactly what is going to be happening here. And some of the work has already been done for us. Like, we've already turned on Host Mobility Manager with the feature fabric forwarding. We've already got the interface VLAN associated. But there's a couple of additional steps that we're going to have to go through in order to make this actually happen. Now, for those of you that are coming from like a Inter VLAN routing perspective, this is very similar in the same concept, where in Inter VLAN routing you want to route from one VLAN to the other, and there's two different ways that you can do that. You can either configure a router or a firewall with that's connected downstream to a switch with a interface that is going to be router on a stick, where you have the switch, the traffic leaves the switch, goes upstream to the router on a sub-interface that's configured to listen for a specific VLAN ID, make the routing decision, and send the traffic back down to the switch. That works out great. There's also the layer 3 switch option, where you have a bunch of switch virtual interfaces which are going to act as the default gateway, which is exactly how we're going to be doing it. We're going to be using the layer 3 switch option, and the way that I like to liken this to a physical capability that some of you might have experience with is the SPIs. I like to correlate those to like an elevator. You're going up and down a multi-story building in between the different floors, and in between the different floors are going to be your different VLANs. Different businesses and stuff like that. So in a situation like that, that's really the correlation that comes into play. But beyond that, that's about where the similarity between Inter VLAN routing and Inter VNI routing are not the same at all in terms of implementation. Inter VNI routing is much more involved. You have to have a deeper understanding of how networking works than you would if you were just doing straight Inter VLAN routing with layer 3 switching. Inter VNI routing requires a VRF to be created. It requires a understanding of how integrated routing and bridging, or IRB, comes into play. Or IRB is essentially the ability to bridge and route at the exact same time. Back in the day, you had concurrent route bridge, which means you could route and you could bridge at the same time, but you couldn't mingle the two together. Where IRB is, you're able to bridge traffic inside of the same VLAN, which is what we've been doing, which is layer 2 VNI connectivity, where we're pinging inside the same VNI between two different Nexus switches, and using VXLAN to bridge that communication over a routed backbone, where IRB allows me to not only do layer 2, but also to leave my network and go to another VNI. So I could go from VNI 10,010 to VNI 10,020. So I can route between VLAN 10 and VLAN 20 inside of the VXLAN fabric. It gives you a lot of latitude in how you go about doing things. So with that being said, that's going to be one of the key things we're going to have to go do. We're going to have to go create a VRF, a virtual routing and forwarding table. What's a VRF? A VRF is a user-created routing table. So if you were to look at any of the 9Ks and do a show IP route, the show IP route is what they refer to as the default VRF, or the global routing table. For those of you that have like a CCNA level of understanding, this would be the same thing as if I'm trying to configure a static route between two different routers, and I want to get from the LAN segment on router 1 to the LAN segment on router 2, and there's a physical link between the two. Guess what? You need to point to the next hop on router 1 to router 2, and so on and so forth. If I wanted to carve the traffic up to where I don't want to have every route in the routing table, I want to go ahead and carve it up to where I have, maybe finance and HR and engineering and IT, they're all logically separated, I can do that too. And a VRF allows me to, it's the same thing as a VLAN on a switch. A lot of people, like when they start learning about VRFs, they get kind of freaked out because they're not used to that concept, because VLANs are immediately introduced to you and they're explained. It's logical segmentation of a switch, right? You create a VLAN, you apply it to ports on the switch, and that allows you to logically segment or segregate the ports on a switch in order to, isolate traffic. A VRF is the exact same thing, but on a router. It's the only difference between the two. So VLAN is to layer 2 as VRF is to the router. Simple as that. So when we take a look at doing that, we're going to separate routing tables. This is more often seen in the service provider world, where the service provider will have a VRF per customer, and then you can allow route leaking in and out of a VRF if you want, but it's usually designed for segmentation. That's what a VRF is mainly designed to do. Same thing as a VLAN. Now the cool thing about this is when we go to create our VRF and get it working, there's going to be this concept of there's asymmetric bridging, and there's asymmetric integrate route bridge, and there is symmetric integrate route bridge. What's the difference between the two? Well, the main difference between the two is with asymmetric IRB, all the VLANs that you want to be able to communicate in between need to exist on all the switches that you need to send the traffic on. Where with symmetric route IRB, that's not the case. If I don't need to run a particular VLAN on a particular Nexus switch, I don't need to. I can only place the VLAN on the leaf switches that it needs to exist on, so that I can create a VNI mapping to that VLAN so that I can send VXLAN traffic between my leaf switches inside the VXLAN fabric. Where isometric IRB takes into this capability a logic known as bridge route bridge, where you bring so the first piece of this is the bridge, where the bridging is also referred to as switching. So I have a PC that on leaf 1 wants to talk to PC 2 on leaf 2. Well, for the first portion of the first B, the bridge, I'm going to allow traffic to come in on the switch port from PC 1 on leaf 1. And it's in VLAN 1, so 10.1.10.13 for example. I'm going to need to send that to another leaf switch for PC 14, for example. What's going to end up happening is you're going to need to route from your, VLAN 20. Sorry, that's what I'm. Let me actually show you a topology, so this will be easier for you guys to follow. Let me go ahead and pull this up real quick. Alright, so I'm going to take this link and I'm going to add it. I'm going to try to remember to add it to the description of the video so that you guys have reference to it. But basically what we're going to be doing as we go through this is what they refer to as symmetric IRB. And basically what ends up happening here is you'll notice with asymmetric IRB, right, you have, let's go ahead and open these both up so you guys can see them better. What you're basically doing here, we'll go ahead and zoom in a little bit. What you're doing is you'll notice that you have VNI A and VNI B both sitting on the same VTEP. Same thing with this one. You have VNI A and VNI B. Basically the same VXLAN subnets, the same VLANs. And what ends up happening here is we have host 1 that's in VNI A that needs to talk to host 2 that's in VNI B. So what you do is you will bring the traffic in on VNI A, right? So you'll have a bridge to bringing the traffic in on the VLAN. Then you're going to have a route. So it's a bridge route bridge. So the traffic comes in and is routed into VNI B. So it's automatically brought into the other VNI. And then from there, so you bridge first. And then the second part here is you are going to route it from VNI A to VNI B. So your Inter VNI routing is done. And then you're going to bridge it over the VXLAN backbone to VNI B over here. And once you do that, you're going to take the traffic out and you're going to dump it down to host 2. And this is where this logic comes into play. Now the reverse of this, go ahead and pull my pen tool up here. So you're going to have this right here where you're going to have traffic come in, hit this guy, then it's going to be routed to here, then it's going to be sent over the wire to this guy, right, and then dumped off here. So it's you bridge here, you route here, and then you bridge here, okay? And then for the return traffic is the same thing. What I will do is I will send traffic up to VNI B. So this will be your bridge. Then you're going to route it to VNI A, which is your route, and then you're going to jump it over to VNI A over here, and then you're going to have a bridge because the traffic will go back out this way. That is what they refer to as a bridge, route, bridge. The drawback to this is your VNIs have to be symmetric across the board, because even if I don't have any users sitting in VNI A, right? If there are no endpoints sitting inside of VNI A on VTEP 4, doesn't matter. I still need to maintain the VNI there so that I have a place to send the traffic when it needs to be sent there. And this is the drawback to asymmetric IRB. It doesn't allow me to scale it the way that I need to. Now, if I look at symmetric IRB, which is this one, it's a little bit of a different flow. So essentially what I'm going to be doing here is I'm going to have a layer 3 VNI. This layer 3 VNI is going to span all the different leaf switches inside the network that need to do any type of Inter VNI routing. So the first thing that I'm going to go do is I'm going to bring the traffic in to the switch to the local VNI. So this will be your bridge. Then I'm going to route it from VNI A to the layer 3 VNI. The layer 3 VNI, this guy doesn't actually have an IP address on it. There's no IP address. It's going to use the IP forward command. We'll talk about that more here in just a second. But what I'm going to do is I'm going to route it to this guy, right? And then, so this will be the route. And then once I get it here, I'm going to send it via VXLAN encapsulation over to here. Right, so this will be VXLAN encapped. And then once I get to here, I'm still not going to be inside of VNIB yet. I'm in the transition point of getting from the source VTEP to the remote destination VTEP where I've got to be. Now I'm going to route from VNI, the layer 3 VNI, here. I'm going to route to here, so this will be the route. And then from here I'm going to push this down to the endpoint that needs it, which means that this will be a bridge. So it's a bridge, route, route, bridge. So I bring traffic in on the VLAN with the VNI mapping, then I route it here. I go between my VTEPs, and then I route from here to down to this guy, and then I send it outbound. And then I just reverse the process. When traffic from VNI B needs to go talk to VNI A and the reverse flow, so we have our, let's say this particular part is our echo request, and I need to reply to the echo request. I'm going to send traffic up. I'm going to get routed to this guy. Then traffic will go back this direction. I'll get routed back over here, and then it'll be a bridge down. And this will be this portion right here will be my echo reply. And that's basically how this is all going to tie in together. This requires a couple of pieces of information. The first thing that I'm going to have to do is I'm going to have to create a VRF. The VRF is, in this case here, we'll use cust1. And then this right here, this VRF, we are going to apply it underneath the SPI of VLAN 10 and VLAN 20 for the ones that currently exist for customer 1. Once we do that, we'll be in really good shape. Then we're going to have to go underneath BGP, and for BGP, we're going to have to, underneath the VRF of cust1, we're going to have to advertise the local subnet. So in our case here, we're going to be using 10.1.10.0/24 and 10.1.20.0/24. On both of these leaf switches, we're going to have to advertise both because we're going to be terminating both VLANs and both SPIs on both VTEPs. So we'll have a SPI here and an SPI here for both. We'll place both SPIs right here inside of the VRF of customer 1, and then we're going to advertise those subnets from BGP. This is going to introduce what they refer to as a type 5 route, which is going to be basically an external route. But what this is going to give us is the ability of bringing in a type, or a, sorry, not a type 5. That's my mistake. That's external routing. We're going to be able to bring in a layer 3 VNI into our EVPN table. And this is going to be how we're going to propagate our routing information back and forth. Before that, the routing wouldn't even begin to work. Now the IP forward command that comes into play here, what this basically is going to allow us to do is to take whatever is being advertised subnet-wise on this VTEP and this VTEP and allow it to be punched over the network via VXLAN. The layer 3 VNI SVI itself won't need any IP addressing on it. Think of it like a, what's the command I'm thinking of? It is the, not the update source, but the, I can't think of what I'm trying to say. There's a way of doing, it's where you set the, it's typically used in MPLS traffic engineering. I'm struggling to remember the command, but I had to actually go look at some notes, and it's the IP unnumbered option, where essentially what will end up happening is traffic will appear as though that it is sourced from the VTEP's IP address on both sides, and that's what's going to end up happening. So we're going to see traffic come in as it basically is IP unnumbered to loopback 0, and that's what's going to allow us to set all this stuff up. So without any further ado, let's go ahead and take a look at the operations and the configuration to this stuff. It's actually not too terribly difficult to follow this config. It's just a little tricky sometimes to get it working the way that you need it to. So with that being said, let's go ahead and take a look at this setup. So the first thing we're going to have to do is we're going to do this on 9K1 out of the gate. And what I'm going to do is I have to go to global config, and I have to create a VNI that's going to be used for the layer 3 communication. So in this case here, I'm going to use, and this has to be tied to a VLAN and as well as a VNI. So we're going to type in VLAN. I'm going to type in VLAN 100. And I'm going to use the VNI of, or VN segment of 100 100. And I'm going to give it a name of VLAN 100. And then I'm going to specify a VRF context, and I create a VRF essentially. And I'm going to go ahead and call this cust1. And underneath here, we're going to specify the VNI this is going to map to. So in this case, it would be VNI 100.100. And then we're going to specify the RD, or the route distinguisher, is going to be auto. And then address family IPv4 unicast, we're going to set the route target both to auto, and the route target both auto for EVPN. So this is going to allow me to advertise EVPN routing information and MAC address information to be the BGP table. So I'm going to go ahead and also I have to go underneath the individual SVIs. So interface VLAN 10. I'm going to go ahead and show run interface VLAN 10. And I'm going to come underneath here and type in VRF member is going to be cust1. Now I'm going to have to go ahead and reapply a couple of these pieces of information. No big deal. No harm, no foul. But that's the first piece that needs to be done. I'm going to do the same thing for interface VLAN 20. Show run interface VLAN 20. And I'm going to type in VRF member is going to be customer1. And then reapply this IP addressing. Okay? Just like that. Now that I have that in place, the next thing I have to go do is I have to update the Nve interface. By doing that, I will be able to advertise the information that I need. So this will allow us to associate the VNIs. We do a show run interface NVE1. This will allow me to associate this layer 3 VNI to these specific VNIs right here. So I'm going to go ahead and type in interface NVE1. I'm going to go ahead and shut it down just for the moment, just so that we can associate this, and we can have a shut no shut event to trigger the update. I'm going to go ahead and type in member VNI, and it's going to be 100.100, and the command is going to be associate VRF. I'm going to go ahead and type in no shut and exit out. And then if I do a show run interface NVE1, you're going to see this associate VRF. Now, the reason why this is going to work is it's not specific to the NVE configuration here, but where it does come into play is we do a show, and we have to create an NVE, a VLAN interface for VLAN 100. So underneath interface VLAN 100, we're going to have to go ahead and say, underneath this guy, we're going to type in VRF member is going to be customer 1, and underneath here we're going to specify IP forward, and then we're going to no shut it. So we're going to do a show IP interface brief with VRF customer 1, and we can see that for 10.1.10 and 10.1.20 that they're both up and running, and that we have forward enabled. The last thing to do is we need to go underneath router BGP 65001, and we need to go create a VRF, and the VRF is going to be customer 1. And underneath address family IPv4 unicast, we're going to advertise the two subnets that were set up that need to be advertised for this particular customer. So 10.1.10.0/24, sorry, network, and then network 10.1.20, just like that. Now, if you haven't already done so, and maybe you missed a step in the past, you're definitely going to want to enable the show run pipe include feature. You're going to need the feature fabric forwarding to be turned on. If we do a show run fabric forwarding, you need to have this capability turned on right here. And you also need to have a specific MAC address associated. This MAC address is going to be associated for everything. So it's not, you don't have VRF specific operations. Once you've defined this, it's defined. And it makes a lot of sense to do it the way that I'm doing it. It works out that way. Now that I've done all that, I'm going to go ahead and basically reconfigure the same thing for 9K3. So 9K3, we're going to do the same thing. So just to recap what we did, we first have to go and create the VLAN. VLAN 100, name is going to be VLAN 100, VN segment is 100.100. We're going to go ahead and exit out of that, and then we're going to go ahead and specify the VRF context is going to be customer 1. The VNI that it's going to get mapped to is 100.100. RD will be auto generated. Underneath IPv4 unicast, we're going to go ahead and we're going to specify route target. Both will be auto, and we're going to add in EVPN. Do and exit out of that. Let's just make sure show run pipe section VRF to make sure that that took effectively. Okay, so I need to go ahead and make sure that I advertise it for not just for EVPN, but just for regular address family IPv4 unicast. So we're going to type in route target both auto. So we do a show run pipe section VRF again. We should have both entries there. Perfect. Then we're going to have to go into interface VLAN 100. We're going to go ahead and no shut it. We're going to put it into VRF member is going to be cust1, and then we're going to IP forward on it. There we go. Then we're going to have to go underneath the interface NVE1. We're going to go ahead and shut it down, but we're going to specify member VNI 100.100 and then associate the VRF. Just like that. We're going to go ahead and no shut that. And then underneath router BGP 65001, underneath VRF customer 1, address family IPv4 unicast, network of 10.1.10.0/24 and 20. Just like that. And again, show run feature, show run fabric forwarding. All of this needs to be applied as well on this switch. If we do a show IP interface brief for VRF customer 1, now we can see that the SPIs haven't been associated yet. So we're going to go to show run interface VLAN 10. We're going to go interface VLAN 10 and type in VRF customer 1, or sorry, VRF member customer 1, and then reapply this information right here, just like that. And then show run interface VLAN 20, interface VLAN 20, VRF member is going to be customer 1, and just like that. Paste that in like so. Perfect. Show IP interface brief VRF customer 1. Excellent. Now that we've done all that, let's go ahead and take a look at, let's go ahead and add in OR BGP. So we're going to get a lot of BGP updates when we do this stuff. OR BGP. So I'm going to go ahead and pull secure CRT back up. Now what I'm going to do is I'm going to jump out of global config and do a show BGP L2 VPN EVPN and hit the enter key. And what I'm going to do is I'm going to scoot this guy up a little bit just so we can see all of it. As you can see, there's not a lot going on here, right? What we needed to go do, and let me just make sure that show run interface NVE1. Perfect. That's good to go there. We're going to go ahead and begin our communication. So we're going to go ahead and do some testing. You'll notice right now there's not a lot of MAC addresses. That's because we flapped our connections. But what I'm going to do here is I'm going to do a debug BGP updates and hit the enter key. Now I'm going to go over to PC13, right? And PC13, I'm going to do a ping of 10.1.10.14. Make sure that I can talk to him, which I can. We know that's working effectively. We look at Nexus 9K3, we hit the up arrow, and see that? We can see that 13 showing up in the layer 2 VNI for 10,010. We're going to do the same thing for PC20. We're going to go ahead and we're going to ping 10.1.20.21. That should work as well. We go to Nexus 9K3. We're going to go ahead and see that that's been added to the routing table, the BGP layer 2 VPN table as well. So hit the up arrow and we should see that for 10,020 we can see that that's been added just like that. Now here's the real test. Can I ping from PC21 to PC20 or PC14? And the reason why I'm doing that instead of PC13 is because PC21 and PC13 are attached to the same leaf switch. I'm going to go to PC21. I'm going to ping 10.1.10.14. And hopefully, if I've done everything correctly, there it goes. It took a couple seconds for it to work, but eventually it started to operate. And I can see the communication happening back and forth. So I have Inter VNI routing set up. We come over here and I do a show BGP L2 VPN EVPN. We can see that underneath layer 2 VNI 10,020 that we have 2020 and 2021. And then underneath VNI 10,010 we have 1013 and 1014. And everything else is looking pretty good. We have some specific information being propagated from both of the source VTEPs, right? So what we're advertising, and basically where this comes into play is we're advertising locally. We're advertising 10.1.10.20 and 10.1.10 and 10.1.20 as the source subnets, and these are type 5s. I'm sorry, these are type 5s. Okay, so I was correct from the get-go, but it's under the layer 3 VNI where these are being advertised. So that is basically what it is that I wanted to show you in this video in terms of how this operation will come into play. So that's pretty much it. Layer 3 VNI is in the books. We're good to go with that one. So with that being said, ladies and gentlemen, I want to thank you guys for hanging out with me in this video, and until next time, guys, take it easy.